So for the parallel force system, if all the forces are exactly vertical, then a resultant R is equal to summation Fy. If all the forces are horizontal, R is equal to summation Fx. So application for parallel force system is suspension bridge, okay, where the columns, they support the weight of the road or the cement concrete. So here Ra and Rb, these are the reactions offered by these supports or the columns, and R is the net effect of the cement concrete or the resultant force. Second example is forces on the truck chassis. So the weight of this rear part, or this is called as a dump weight. Okay. So this weight get transmitted on this chassis. Okay. So it will be a parallel force system. So you can observe here, this is the truck chassis. So all the weight of the truck, it will act exactly in the downward direction. So these are the vectors. So this form one parallel force system. So if you compare the concurrent force system, suppose we have one concurrent force system. This is the point O. And we have the forces F1, F2, F3. Okay. So whenever we calculate the resultant for the concurrent force system by this formula, R is equal to square root summation Fx square plus summation Fy square. Okay. We know that resultant will act at this point only. That is a point of concurrency. Okay. Suppose this is the result. And then we can find out the angle with respect to x-axis, which is a theta. Okay. But in case of parallel force system, so suppose we have a rod AB. Okay. So on this rod AB, there are three forces like this: F1, F2, and F3. Okay. We know the equation for resultant force. R is equal to, as all the forces are vertical, so resultant will be summation Fy only. So from the calculation, we will get some answer. But how to decide the exact location of this resultant? Okay. So whenever you want to show the resultant on this diagram, that is a object AB, suppose resultant value is negative. Okay. Let us take, we get the resultant as minus 80 Newton. Okay. Just consider this example, minus 80 Newton. So minus 80 means resultant is in the downward direction. So this is the R, which is equal to 80 Newton. Okay. But how to find out this distance with respect to point A or point B? In case of concurrent force system, we know the exact distance. Resultant will definitely start from this point. That is a point of concurrency, because remaining all the forces, they are passing through the same point. But for parallel force system, we cannot decide directly the position or location of the resultant with respect to a given point. Okay. So for that, there is one theorem that is called as a Varagonas theorem. So Varagonas theorem, it is used So it gives the location of resultant with respect to a given point in the system. Okay, so its statement of the Varagonas theorem is the algebraic sum of moments of all the forces in the system about a given point is equal to the moment by the resultant force about this same point. Okay, so this is the Varagonas theorem, and by using this theorem, we can find out the location of the resultant with respect to given point of the system. So let's try to understand this statement with the help of the example. So here we have one object AB. On this object, there are three forces, F1, F2, F3. Okay. Their distance, they are given with respect to point A. So this is L1, this is L2, and this is L3. Okay. Now the resultant for this system, we can find out by this formula, R is equal to summation F1. Okay. So here this will be, just observe the direction. So I will consider this 10 Newton, F2 20, and F3 30 Newton. So F1 is minus 10, minus 20, and plus 30. Okay. So let us change the value. Make this 50. So minus 10, minus 20, and plus 50. So you will get the resultant. This is equal to 20 Newton. Okay. So 20 Newton means resultant will definitely act in the positive y direction. Now question is, what is the location of the resultant with respect to point A or point B? So this can be given by this Varagonas theorem. Okay. So for the Varagonas theorem, your first line, the algebraic sum of moments of all the forces in the system about a given point. That means we have to take the moment by individual force about point A, and we have to add all these moments. So this is written as, so by Varagonas theorem, so the mathematical equation for Varagonas theorem is, this is algebraic sum, which is summation of moment by all the forces about a given point. So given point is point A. This is equal to moment by the resultant about the same point. Okay, that means when we replace the system by resultant system, we have to take the moment about the same point. So this is original system. I will draw here the resultant system. So this is the resultant system. Okay, so the object will be same, which is the AB. We know the resultant 20 Newton. So this is the upward direction. So here R is equal to 20. Just we don't know this distance. Okay, so I will assume this as a D. So D is the perpendicular distance. Now concentrate on this left hand side. Okay, what is the left hand side here? Summation of moment by all the forces about point A. So summation of moment by all the forces about the point A, this is equal to. Now take the moment by individual force. Okay, so consider the first force F1, which is 10 Newton. So 10 into, what is the moment? Moment is nothing but force into its perpendicular distance. Okay, so moment is clockwise, then we take this minus, and if the moment is anti-clockwise, we take this as a positive. Okay, so this is a sign convention. So here 10 Newton, its perpendicular distance with respect to point A, this is a L1. Okay, and this moment, whether it is clockwise or anti-clockwise, how we can decide? For that, we have to observe the sense of rotation. Okay, so just imagine you are holding the point A in your hand. Okay, and then you are applying the force F1 on this rod AB. So how the rod will going to rotate? It will have the tendency to rotate in this direction because of this 10 Newton. Okay, just forget about the remaining forces. Because of 10 Newton, the complete rod AB, it will rotate in the clockwise direction about the point A. So this moment is clockwise. So it is minus 10 into perpendicular distance, which is L1. Next is 20 Newton into its perpendicular distance is L2 with respect to point A. Again, this moment is clockwise. So it will have tendency to rotate the rod AB in the clockwise direction. So this is again negative. Next is 50. Its perpendicular distance is L3. And this moment, it will try to rotate the rod AB about the point A in the anti-clockwise direction. So it is positive. Okay. So if you consider some value for L1, L2, and L3. So let us take this L1 as a 1 meter, L2 2 meter, L3 3 meter. So this is minus 10, minus 40, and plus 150. Okay, so your total answer will be 100 Newton meter. Okay, because this is summation of moment. So for the moment, unit is Newton meter. Okay, so this is left hand side for the Varagonas theorem. So we have got the answer, summation of moment by all the forces about A, it is equal to 100 Newton meter. Okay, so we have got the positive answer. Now refer this diagram, which is a resultant diagram. So this is a AB. This is the resultant. Right now we don't know the exact distance, so we have assumed it as a D. Now the right hand side of the Varagonas theorem is moment by resultant about this same point. Now take the moment by resultant. R into D. This is the moment by resultant. And what is the sense of rotation? So imagine point A is fixed and we are applying the force R on the rod AB at distance D. So it will rotate the system in this direction, that is in the anti-clockwise direction. Okay, so this moment R, this is equal to R is 20. Okay, so this is equal to 20 into D is unknown distance. So our aim behind using the Varagonas theorem is we have to find out the distance D. Okay, now equate this summation of moment. This is equal to moment by the resultant about the same point. This is Varagonas theorem. So left hand side is 100. This is equal to 20 into D. So finally you will get D is equal to 5 meter. Okay, that means at distance 5 meter from the given point A, so at distance 5 meter, we will get the position for the resultant. So if you want to show the resultant on the original system, so this is the object AB or rod AB. This is the first force F1. This is F2 and this is F3. Okay. This is 1 meter distance. This is 2 meter and this is so L3 we have taken as a 3 meter. Okay. So this is 3 meter. So somewhere here, this is F3. Okay. So at 5 meter distance, you will get the result. So this is the resultant. And this distance with respect to point A, this is equal to 5 meter. Okay, so this is the use of Varagonas theorem, because in case of parallel force system, we cannot decide the location of the resultant with respect to any one point. Okay, so for that we can use the Varagonas theorem. Okay, so note down this first problem on the parallel force system. So here rod so rod AB is subjected to 4 forces. Find the resultant R and position of the resultant with respect to point A. So for the parallel force system, the equation is R is equal to summation Fy. Okay, because here all the forces are vertical. So just consider positive or negative depending on the direction. So first is minus 30, second minus 60, plus 20, minus 40. Okay, so R is equal to, so this is minus 90, minus 130 plus 20. So minus 110 Newton. Okay, so what is meaning of minus 110? Actually, R is equal to 110 Newton. It is acting in the downward direction. Okay, so this is the resultant force. Now, next step is we have to find out the position of the resultant with respect to point A. So this position you can find out by using Varagonas theorem. So just I will redraw this rod AB. Now we know the resultant acting in downward direction. So this is R, which is equal to 110 Newton. Assume the position from A as a D. Okay, so D is the perpendicular distance with respect to point A. Now this system, it is equivalent to the original system. Okay, so both will have the same effect. Just we have replaced the system of forces by the resultant force. So what is the Varagonas theorem? So just write the equation: summation of moment by all the forces about any point. So in the problem, we want the position with respect to A. So take here A, this is equal to moment by resultant about the point A. Okay. Now observe the left hand side. So for the left hand side, we have to take the moment by each force. First is 30 Newton. About A, its moment